I am residing at Anand. So today the topic of my YouTube is nutrient management in forage and horticulture crops. So I have served in Main Forage Research Station, Anand Agriculture University from 1982 to 2006, and I am looking the quality as well as forage crop production. So improvement of forage quality through nutrient management. So nutrient management plays a significant role in increasing quality of forage crops. One field trial was conducted on well-drained sandy loam soil at Main Forage Research Station, Gujarat Agriculture University, Anand during monsoon Kharif season from 2000 to 2002 to study the effect of phosphorus and sulfur application on yield and forage quality of sorghum. Another field trial was conducted on similar type of soil during the winter, summer and monsoon Kharif seasons of 2003-04 at the similar place at Anand to know the effect of phosphorus and potassium on lucerne crop. We have also conducted a trial on the Kagji lime, means acid lime, Citrus orientifolia, for the soil application as well as the foliar application to elevate the iron chlorosis. So first we see the effect of phosphorus and sulfur application for yield quality, nutrient uptake and cyanide content of forage sorghum. You know that when we are harvesting the forage sorghum crop, then it contains the hydrocyanic acid, means cyanide content, and when we feed to the animal, then there will be poisoning effect. So we should have to harvest at first cut at 60 days after sowing and subsequent cut 45 to 50 days after this first cut. So considering the net ICBR, increment cost benefit ratio, yield and forage quality production point of view, combined application of phosphorus at the rate of 40 kg phosphorus and sulfur at the rate of 20 kg sulfur per hectare to sorghum gave higher green forage and digestible dry matter yield as well as net ICBR. We have also observed that by the application of 40 kg phosphorus and 20 kg sulfur, the cyanide content in leaf and shoots significantly reduce. So it is advantageous. It not only increase the crop production, forage production as well as quality, but it reduce the cyanide content and also the fiber content in forage sorghum. So here you can see the clear-cut difference. Here the control P0, S0, and here P40 and S20. So it is a recommendation. And the variety, we have taken two variety. One is SSG 59-3 and another is hybrid GFSH1. So you can see the growth at 13 days. So effect of phosphorus and sulfur on forage sorghum variety, sweet Sudan grass 59-3 at 13 days growth. Then we also obtain the phosphorus response. Here you can see phosphorus 40 kg and sulfur 0. Here the control plot P0 S0. So at 13 days of the growth, we observe the better growth of P40 S0 as compared to the control plot. So from the results, we have made recommendation to the farmers that the results have indicated that for growing for a sorghum variety SSG 59-3 in monsoon Kharif season in soil having medium ability of phosphorus and deficient level of sulfur, the farmers are advised to apply 40 kg phosphorus in form of 87 kg DAP and 20 kg sulfur in form of 133 kg gypsum per hectare every year to obtain maximum forage yield, total returns, net increment cost ratio, and better quality, means crude protein and digestible dry matter production, DDM production of forage. This level also remarkably reduce the cyanide content, I told, SCN in leaf 11 to 33%, and soot 12 to 156% of forest sorghum. The lowest neutral detergent fiber content was found with 40 kg phosphorus to SH59-3, a common basal dose of 25 kg nitrogen at the time of sowing, 25 kg nitrogen at the time of 30 days after sowing, and 25 kg nitrogen per hectare after the first cut. That is 60 days should be applied. So we also got the Professor Hariom Asram Award for carried out the significant contribution in soil science for continuous in a monsoon season as well as in summer season. Then lucerne. So early lucerne crop sown in the first week of November and second week of November produce higher seed yield 412 and 337 kg per hectare respectively over delayed crop sown on last week of November and second week of December, 341 and 337 kg respectively under middle Gujarat conditions. So this experiment has been conducted in Rabi season, winter season for 3 years, and on the basis of the results, we have carried out the pool analysis and we have made the recommendation to the farmer. So these results indicate the sowing of lucerne is a beneficial when we are made first week of November or second week of November. So delay the sowing of the lucerne, drastically reduction of the seed production of the lucerne. Then early sowing of lucerne crop in the last week of October. So that experiment was conducted at Anand, and this experiment, same type of experiment was conducted at North Gujarat condition where the soil is sandy soil. So early sowing of lucerne crop in the last week of October and second week of November produced significantly higher seed 233 and 196 kg per hectare respectively over delayed crop sown in first week of December, 172 kg per hectare under North Gujarat condition. Sowing of lucerne on last week of October along with 80 kg P25 per hectare produced significantly higher seed yield 268 kg per hectare than other interaction under study. So the soil type of the Sardar Kushinagar in North Gujarat is sandy soil. So say the seed yield is comparatively lower as compared to the Anand. But here we also observed that early sowing is beneficial and we have to sow the lucerne in the last week of October or second week of November. And we observed that delayed sowing first week of December drastically reduction of the seed yield of lucerne. Then we have conducted this experiment on. So the farmers of Middle Gujarat agroclimatic zone 3 growing lucerne variety GL1. So it is a well-known, popularly known as Anand 2 in Gujarat as well as throughout the India are advised to apply 40 kg sulfur per hectare in the form of gypsum 300 kg per hectare in soil having sulfur status marginal to obtain higher seed of lucerne and net return. So the soil of the Anand is sandy loam type. So the soil of the Anand district having 40 to 50% soil having the sulfur status marginal to deficient. So therefore we have conducted the trials and we have observed that application of 40 kg as per hectare produce the higher seed yield of lucerne as compared to the control. You know that in a Goradu soil, sandy loam type of soil, also the deficiency of the zinc. So we have conducted a trial on zinc for 3 years. So application of 25 kg zinc sulfate per hectare recorded the highest net return per hectare and net incremental cost benefit ratio, and it was found one of the most remunerative treatment in soil having marginal zinc status for obtaining higher lucerne yield. So in marginal zinc status also we are getting the response of the 25 kg zinc sulfate per hectare. Then response of 300 kg K2 per hectare over 150 kg K2 per hectare. So You know that potassium is responsible for persistence of dilution. So at present in Gujarat, the recommendation dose of the phosphorus is potassium and phosphorus is 50 kg per hectare. But we have taken P50 and K300. So you can see here the plant population. So we are getting the response of potassium, and that experiment has been conducted for 1.5 years. So you can see the response of the phosphorus. So on the basis of the trials, the farmers who are growing lucerne variety GL1 or L3 as a perennial for 1.5 years in winter rabi season, soil having rich available phosphorus and medium in potassium fertilizer advised to fertilize dose of 300 kg K2 per hectare in first year and 225 kg K2 per hectare in second year, 150 kg K2 per hectare in rabi and 75 kg K2 per hectare in summer to obtain maximum green forage, dry matter and cool protein yields. Net return rupees 19,117 per hectare and net increment cost benefit ratio 1:3:08. Means we spend 1 rupees, we are getting 3.08 rupees. So the marginal farmer can use potassium fertilizer dose of 150 kg K2 per hectare in first year and 120.5 kg K2 per second year to obtain fairly higher forage yield. Net return rupees 9,659 per hectare and net increment cost benefit ratio 1:3.12. The potassium fertilizer should be applied in 3 splits in a year. That is 50% basal, 25% each at beginning of summer and monsoon, Kharif seasons. A common dose of 50 kg or 70 kg phosphorus per hectare and 25 kg nitrogen per hectare should be applied once at the time of sowing. So you know that lucerne is a leguminous crop, so it requires booster dose only at the time of sowing. Only 25 kg nitrogen per hectare is sufficient. Then I did PhD at Sardar Kushinagar, CP College of Agriculture. So we have conducted, I have conducted 2 trials, one on soil application and another on foliar application. So I am presenting here the trial of the foliar application. So response of foliar spraying of ferrous sulfate plus citric acid to acid lime means Kagji limes. So here you can see that ferrous sulfate 0.25% spraying along with the citric acid 0.025%. Here ferrous sulfate 0.50% plus citric acid 0.05%. So after second day's spray of the second day of the spraying, we could obtain the better result. So you can see here we got the greening spot on the leaf. In control plot, you can see it is a clear-cut iron chlorosis. So in iron chlorosis, vein remain greens and other portion become chlorotic. So recovery of the iron chlorosis has been started by spraying of the ferrous sulfate along with the citric acid. Similarly, you can see here the control plot. Here the left side ferrous sulfate 0.25% plus citric acid 0.0025%, and here we can see that here better response of the ferrous sulfate at the rate of 0.5% along with citric acid 0.05%. So elevation of iron chlorosis by foliar spraying of ferrous sulfate plus citric acid. So citric acid helps in translocation of the iron to the shoot and leaf portion. So there was a immediate recovery we observed. So suggestion, control of iron chlorosis. The results suggest that the spray of 0.1% iron as ferrous sulfate in 0.05% citric acid solution prove more effective compared to other treatment in controlling design chlorosis. Also, IS-1C treatment having ferrous sulfate 0.25% and citric acid 0.025%. Foliar spray can control the chlorosis of the citrus spray. So we got more response at the rate of 0.05% citric acid along with the 0.1% iron as ferrous sulfate as compared to 0.25% ferrous sulfate along with the citric acid 0.025%. Then 2009-10, we have conducted one trial at Sansoli in Khera district. So there are 16 treatments. So 2 fertility level, control and recommendation of fertilizer, maize crop 80-40-0. Then 8 levels of biochar, 5 tons biochar of cluster bean, corn store biochar and wood biochar. Then 10 ton biochar of cluster each on biochar and wood biochar, and 7 treatment, 5 ton farmyard manure and 10 ton farmyard manure. So totally 16 treatment combination. And I have prepared the biochar using the simple method of biochar preparation from corn stover means maize stover and cluster bean stover using 2 cleans using the slow pyrolysis method. So settling of organic residue, we have taken 2 cleans, one is bigger size and another is smaller size. So in smaller size, we have filled up the stover, either corn stover or cluster bean stover, then put up upside down in a big, and whatever the space we have put up the wood to give the heat. So thermal decomposition and the temperature was 250 to 300 degrees centigrade. So you can see here the exhaust. So liberation of gases, methane, carbon dioxide, carbon monoxide, and it is a myself photo, Dr. P.C. Patel. So final product on means maize store biochar, and we have tested on the maize crop. So we observed that effect of biochar on dry matter yield in presence and absence of recommended dose of fertilizer on corn means maize crop. So you see here that the application of 3 types of biochar: corn store biochar, cluster beans store biochar, and third one I have purchased from the market, that is Prosopis julifera subabul biochar or FIM with recommended dose of fertilizer significantly increased diameter yield by 3 to 4 times as compared to similar type of 3 biochar or farmyard manure without RDF. So here recommended dose of fertilizer along with the biochar, we got 3 to 4 times higher diameter yield as compared to alone biochar. So you know that in biochar, the nutrient content is less, but it helps, it works as a catalyst, and it helps in increasing the cation capacity because it has the more surface area. It helps in retention of the nutrients, so it reduces the leaching loss. So whatever the nutrients we are applying, that has been utilized, so it increased the fertilizer use efficiency. Then it is the habitat for the microorganism, so microorganism population is also increased. So biochar increase the physical, chemical, and biological properties of the soil, and the soil of the experiment was sandy loam, mean poor in soil fertility. So I have gone through the literature and observed that the biochar gave significantly higher in poor or medium type of fertile soil, and in highly fertile soil, it will not give the response. Recently, in a temperate climate, the response of biochar is lesser, or no response as compared to tropical climate. So India is situated in a tropical climate, and we are getting the response. Other research workers also observe the similar type of results. So you can see here maize flour, corn flour biochar at the rate of 10 metric ton per hectare, along with the recommended dose of fertilizer. We are getting 94.4 quintal per hectare dry matter yield. Whereas here the maize flour biochar 5 ton, so you observe only 23.79 quintal per hectare dry matter. So application of maize flour means corn flour biochar at the rate of 10 metric ton per hectare, along with the recommended dose of fertilizer. So taller plant height, you can see here taller plant height, and gave 4 times higher dry matter yield, mean 94.4 quintal. Then alone soil application of maize flour biochar. So we obtain only 23.7, so 4 times greater when we apply the maize flour biochar along with the recommended use of fertilizer. So on the basis of the results, we have made the suggestion to the farmer that a response of biochar on maize. So it is suggested that application of corn flour biochar at the rate of 10 metric ton per hectare in combination with recommended use of fertilizer, nitrogen, phosphorus, potassium 80-40 kg per hectare respectively, improved dry matter and crude protein yields of corn crop followed by corn flour biochar application at the rate of 5 ton metric ton per hectare in combination with recommended dose of fertilizer. And it also beneficial for build up nutrient in soil. So after carried out the soil analysis, after carried out the field experiment, we have taken the soil sample, and there was the build-up of the nutrient in a treated plot, either 10 metric ton per hectare along with the RDF or 5 metric ton per hectare along with the recommended dose of fertilizer to maize crop. So I have narrated my research work done in at Anand Agriculture University, and if you have any query regarding the nutrient management in forage crop or as well as agriculture crop or horticulture crop, then please write me. And if you have liked my video, then don't forget to subscribe me. Thank you.